Making calls to save Earth.
Moshi, moshi.
Green forces, do you copy?
Hey guys! Wait, you seem to be a little grimy, Polar Bear. What happened?
You'll never guess what I have in the hands. It's awesome.
That black stuff? What is it?
Carbon.
You're so dirty you look more like a black bear. Are you going to throw a barbecue party?
No, this little piece of carbon sucks up CO2.
That's not possible. CO2 only makes up 0.04% of the air that we breathe. Capturing just the CO2 is absurd.
Silly Polar Bear, always finding weird stuff on the street.
But it's true. Let me call up Josh, the genius that created this. Moshi Josh, can you help us?
This is our capture material. It is a monolith that is composed of activated carbon and coated with a special blend of chemicals that's reactive with CO2. They're three-dimensional materials that have air channels that flow through two opposing sides. They were initially developed by the automotive industry as a way to clean up tailpipe emissions.
So it's like a filter.
Kind of, yeah. So in the first phase, we're capturing CO2 with this material, and the CO2 is binding to the surface of this material, which, by the way, there's lots of. This material has about 500 square meters per gram of surface area, which is huge. In the second phase, we seal up the equipment, we turn on electricity, this material up, the CO2 comes out, and then we pass that off to our partner that is going to be performing underground CO2 injection, and they inject it underground for permanent removal from the atmosphere. And we chose this specific type of monolith, two key reasons. One, because of everything I just said about the fact that it's used in high amounts. So we don't have to scale up the manufacturing and supply of a new product. Instead, we can tap into things that already exist, so we will be able to scale faster. The second and more interesting reason that we use this, though, is because this material is electrically conductive. What that means is that unlike almost every single other direct air capture company, which has to use some sort of big heating device like an oven or a kiln or steam generator to get energy into the equipment, we can just add the energy directly to the material itself. The way we do that is via the direct application of electricity. It heats up incredibly quickly as well. This material reaches about 150 degrees C, which is higher than our regeneration temperature in less than 4 minutes after starting from an ambient temperature. So it's an incredibly efficient way to get energy into these types of materials, and we were able to cut the inefficiencies that are typically involved with using big heating devices as we do that. And then the final one is material availability. And what I mean by that is, are you going to be able to, assuming you've done equipment design well and assuming that process energy requirements, carbon requirements are good, do you have everything you need to build? Right? Do you have everything you need to scale? Some companies like ours, the answer to that is designed from the beginning to be yes. We bought these on Alibaba, actually, for our initial prototype testing. We won't be doing that in the future, but it was something cheap and easy. I was one of the project managers on the Model 3 program. My time at Tesla was incredibly insightful in...
Did you sleep in Numi?
Spent a lot of hours. So what I'll say instead is that Tesla did a lot of work in automation. They did a lot of work in high volume production. They did a lot of things that worked well. We did everything from commercializing industrial production equipment to building a 930-foot long structure behind the factory that now builds Model 3s and Model Ys. Tesla's true innovation was in developing the car around the entire electric powertrain. So at the system level, anybody could buy batteries, but they were the first ones to make something that's truly 10x better. I'm thinking about our process in a similar fashion, where there's a lot of engineering and care that's going into every single step of the process, from raw material manufacturing through equipment assembly and design, all the way through final carbon removal. Just building something from the ground up in that way is, you don't really get to see that often. And how many times has that happened in our society? But if you really think about what's going to need to happen to solve this problem, we need so many more of those to happen over the next 10 years, so many more of those first-time scale-ups of a revolutionary product-changing technology or approach. And so I hope that, and what we're building for here is that Noya will be one of those.
See? I told you. Carbon can capture CO2.
I feel bad for calling it barbecue charcoal.
It looks like carbon removal is a hot commodity. Big-name players like Y Combinator and Low Carbon Capital are also invested in Noya.
If that's the case, I could make a fortune by putting the carbon cubes all over my house.
Wow, you really are a greedy little popsicle. moshi 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 moshi